right? So 0 degrees, 30 degrees. You could. And you could do 360. Let's talk about the angles in radians. Now, if you get stuck, go do a side note and do the fourths and the sixths. You remember that day I did that and I counted 1/4, 2/4, 3/4, 4/4. I remember that. Are y'all getting where you don't have to do that part and you can just label them, or do you want me to go back to that? Okay. So I'm going to start with a picture of the fourths. And then I'll do the sixths. Do you agree this is 1/4 pi, 2/4 pi, 3/4 pi, 4/4, 5/4, 6/4, and 7/4? Yep. So this 45 is pi over 4. This one's pi over 2 because it was 2 pi over 4. Okay. See how I'm getting that? This is 3 pi over 4. 4 pi over 4, which is pi. 5 pi over 4. 6 pi over 4, which is 3 pi over 2. And 7 pi over 4, which makes that 8 pi over 4. You can put 2 pi. You could also put 0 radians. Either way, that's the same thing. It just says the label 1 radian, 1 degree. It's 0 radians, it's 2 pi radians. Any questions about those? Now let's draw another picture for the 30, 60, 90. We're going to break the quadrant up into sixths of pi. This would be 1, 6, 2, 6, 3, 6, 4, 6. See, I'm getting that. Okay. So 1/6 would give me the pi over 6. 2/6 would give me pi over 3. And you probably remember we said if it's over 3, it's a 60-degree angle, so you can kind of see that too. This one would be 4 pi over 3 pi over 6, 4 pi over 6, which is 2 pi over 3. And you could also, it's just a second pi over 3, right? It's a second 60-degree angle, so that's another way to do that. This one would be 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, which reduces to 4 pi over 3, 9 pi over 6, I've already done that one, 10 pi over 6, which reduces to 5 pi over 3, whoops, and 11 pi over 6. So that was fun. Now we're going to do the sine and cosine of each angle. Up until this point, this circle has been pretty meaningless to you, right? It's just labeling things you could have found another way. When we start to label the sine and cosine of each value, that's when this circle becomes powerful for memorization. See that as we go. For no apparent reason to you, I'm going to put cosine as an x-coordinate and sine as a y-coordinate. We'll talk about y on the next slide. So as on the x-coordinate, I'm going to put cosine. On the y-coordinate, I'm going to put sine. So what's the cosine of 0? 1. What's the sine of 0? What is the cosine of 30 degrees? What is the sine of 30 degrees? What is the cosine and sine of 45? What's the cosine and sine of 60? 1/2 square root of 3 over 2. And then what's the 45 is memorized already. Yeah. So, and then the 30/60, it's radical 3 over 2 1/2, and then 1/2 radical 3 over 2. So like you could probably memorize that.
What's going on?
So they found the sine and cosine. They put cosine first and sine second. Drew a triangle. Drew a triangle. She's probably worked on.
I'm looking at.
Oh, well,
That's why.
okay, so I'm going to draw a triangle.
Just right there.
Okay, now do you know how we would get that? Draw a triangle. 30-degree triangle, sine would be 1/2, cosine would be radical 3 over 2. So this is like your homework has been the last 2 nights, right? So just answering those questions, just lots of those questions. Up until this point, this is not a powerful thing. But I do want to tell you what it is before we go on. Put those up. Put those up. I want you thinking.
Hey, put it up.
Okay, so let's explain what's going on. So someone very creative realized that they're going to have to answer questions like, what's the sine of pi over 4? Or what's the sine of 3 pi over 2? They're going to have to answer those questions a lot. And so they decided, I'd like to memorize that. And the unit circle is a memorization tool. What the unit circle is it is a circle of radius 1. Okay? And every coordinate gives you the cosine value and sine value. And let me show you why. Would you agree that there is a 30, 60, 90 triangle with hypotenuse of 1?
Yes.
What would this side be?
1/2 of that.
What would this side be? Did everyone agree by dividing to get those sides? Do you agree that the x value is now the cosine and the y value is now the sine? So they created a bunch of triangles with a hypotenuse of 1 to get the sine and cosine values to be the x and y value on the coordinates around it. Up until this point, you're like, well, why wouldn't I just draw a triangle, right? Because drawing a triangle is quicker. And I'm not saying that next year when you forgot the unit circle, you won't go ahead and just draw another triangle. But here's what's important and powerful about the unit circle. If those truly are coordinates, x, y coordinates, then without drawing any triangles, what's this coordinate? Does it have the same x and y value as that one? Except, what's negative?
Negative x.
So it's only like a fourth of the Oh, okay.
So you remember
So I memorize one
I
thing,
got it.
one quadrant, and I can get all 4 quadrants from that. That's where the unit circle is powerful. Is that I can memorize one set of points and I can use those to find any others on the circle. So, what would the 45 be in the second quadrant?
Negative square root of 2 divided by 2 is square root of 2 divided by 2.
And what would this one be?
Negative square root of 3 over 2 over 2. I got it.
Okay, is that the same thing you'd get by drawing triangles? Yeah, back at your homework somewhere. That's the same answers you got a couple of days ago. The unit circle's weakness is that it doesn't have secant, cosecant, and cotangent on it. Or tangent, for that matter. It only has sine and cosine. So really quick before I finish the unit circle, let's talk about how we could use this unit circle to find the others. Tangent, we know is opposite over adjacent. So it would be the y value over the x value. So you would divide square root of 2 over 2 by negative square root of 2 over 2. So that's how you would get the tangent, is you would divide the y by the x. For secant or cosecant, you would flip the sine or cosine value, which makes sense. That's what we've always done, right? So you can get the others, but the weakness of this is the other 4 trig values. There is still value and merit in drawing triangles if you can't remember something, right? We're not getting rid of drawing triangles. This is just for speed purposes. You teachers make you memorize it, and that's not on accident. I teach it a little differently. It's not because I don't want you to memorize it, it's just because I'm a realist. And I've seen people not still have it memorized by the time they get to calculus. So that's why I want you to be able to recreate it if you forget. But memorization, it comes up so often in calculus that memorization is good. Now let's also talk about the quadrantal points at this point. Of course I can just flip it, but this also gives you a way to memorize those quadrantal angles. You know, last night you had to really think about it or look at those charts. If we are truly on a unit circle, circle radius 1, what is the x and y coordinate on a coordinate plane here? And so I now know the cosine and sine at pi. So it's another way to recreate those quadrantal angles if you've forgotten those. The unit circle is good for that too. Any questions so far? Now it's just a matter of changing signs, isn't it? In the third quadrant, what's the signs of all the points? Both negative, right? And what about 270?
0, negative 1.
So the cosine is 0, the sine is negative 1. 300, same as that one, except what's different in quadrant 4? Positive and then negative. X is positive, y is negative in quadrant 4.
You only have to remember one.
Yeah, you only have to remember quadrant 1 and then you can.
Now make this one actual flip, because the other one's just flip.
True. For 30, 60, 90. Why is a 30, 60, 90 flipped?
Same triangle, just flipped.
The same triangle, but the opposite and adjacent sides are switched. Makes sense. And so this one is 1 half negative 3 over 2. Radical 2 over 2. Negative radical 2 over 2. And radical 3 over 2.
Looks like here.
Up here. Any questions about that? This is the unit circle. That's what we're learning today. So, summarize. Unit circle is a circle, radius 1, and the angles on that circle, this cosine and sine, the x and y values on that circle generate the cosine and sine values of the angles on the unit circle. So that's nice to have. X is the cosine value, y is the sine value. For some reason, people have a really hard time with that. The biggest mistake people make is switching sine and cosine on the unit circle. Why is cosine the x value?
So you're going to explain it the next time.
Why would cosine be related to the x value?
Because X is the first one and C is the fourth.
Right? If I do really draw a triangle on here, isn't the x value the adjacent side? So adjacent over hypotenuse, if hypotenuse is 1, then the cosine is going to be the adjacent side or the x side. Y is the opposite side, which is the sine. So that's why. Any questions about the unit circle?
Explain that last part again.
Cosine is adjacent over hypotenuse. If the hypotenuse is 1,